Hello once again, dear children. Now let's go to the part 2 video for the lesson Fun with Magnets. In this lesson, you're going to learn about the properties of magnets. You'll also be able to test for a magnet. That is, you will be able to test if an object is actually a magnet or not. We'll identify some day-to-day applications where magnets are used, and you'll also learn how to take good care of your magnets so they last you a long time. A magnet cannot exert its force of attraction beyond a certain range of distance. That is, for a magnet to attract some magnetic material, it has to be within a certain distance. Only then can it attract it. So the area around a magnet in which there is magnetic force is called its magnetic field. Right? So is there any way in which we can see this magnetic field? We can see the magnetic field, or we can at least get a sense of the magnetic field by performing a very simple activity using a bar magnet and iron filings. Iron filings are basically shavings made up of iron. So let's take a look at this very short video.
You can see that the iron filings, which are here and here and here, are not attracted towards the magnet because this is the extent of its magnetic field. The north side of the magnet is marked with a red dot. If I lift the magnet, you can see that the field is actually three-dimensional. It goes all around the magnet. The magnetic field is made up of magnetic field lines which go from north to south, from the north pole of the magnet to the south pole. So it is made up of many such magnetic field lines. The magnetic field is made up of many such magnetic field lines. That is why you can see the iron filings form a spike-like shape around the magnet.
So now that you've seen what the magnetic field would actually look like, where will the force of attraction be more in a magnet? Will it be at the center? Will it be at both poles? Or will it be at just any one pole? Now think about what you saw in the video, the way the field looked, and try to answer. Justify your answer. Yes. So the magnetic field is always strongest at its poles, at both poles. In fact, you can see that the field lines are maximum, or all the field lines would begin and end at the poles. So therefore, the magnetic field is always strongest at its poles and never along the magnet, along the length of the magnet or the center of the magnet. It is always at the poles that the magnetic field is the strongest. Let's take a look at the properties of magnets. The first property of magnets that we're going to look at is something that you're already familiar with. That is that all magnets have two poles. You must have noticed that magnets can attract other magnets using one end and then push away or repel another magnet using the other end. That is because they have two distinct poles, the North Pole and the South Pole. The like poles, that is, the same poles of two magnets are brought together, they basically push apart each other, and this is what is called as repulsion. When the unlike poles, that is, the opposite poles of two magnets, are brought towards each other, they attract or they come closer to each other immediately on their own, and that is what is called as the property of attraction. So, depending on whether the like poles or the unlike poles are facing each other for two different magnets, magnets can either repel each other or attract each other. Like poles are similar poles and unlike poles are dissimilar poles. The second property of magnets is called as the directive property. What is the directive property? When a bar magnet is suspended freely, it would always point towards the geographical north pole or the north direction of the earth. This is what is called as the derivative property of magnets. We already saw that magnetite is otherwise called as lodestone or leading stone, and the reason for this is that it was used by navigators or sailors in that period of time to find out which direction is north when sailing in the open sea. This is because it would always point towards the north direction. This property, where does it come from? For this, you need to remember what we have learned about the layers of the earth in grade 5. We learned that the earth is made up of several layers, namely the crust, the mantle, the outer core, and the inner core. And the inner core is kind of a solid material made up of iron and nickel. And what happens is that this inner core is actually moving, it is actually spinning, or it is moving round and round inside, deep inside the earth. And this causes the formation of the magnetic poles of the earth. So the earth itself acts as a huge bar magnet, which is having a north pole as well as the south pole, and this is how it would look. Yes, strange enough, the north pole of the Earth's bar magnet is actually facing towards the geographical south pole, or Antarctica as we call it. Okay, and the south pole of the Earth's bar magnet is facing towards the geographical north pole or the Arctic Circle. But do not get confused with this. We still called the end of our magnet, which faces towards the North Pole, the geographical North Pole, that is the Arctic, as the north side of that magnet, and the opposite side as the south side of that magnet. So, this is what leads to the directive property of magnets. Now let's take a look at the working of a compass. What is a compass? A compass is actually a magnetic needle. The black needle having the north and south indicated. It is actually a magnetic needle, and it is pivoted, or it's free to rotate on a point. Okay, and around it what is indicated is the different directions. So depending on which direction you are going, it would actually point always towards the north pole, and that would actually show you in which direction you are moving, whether it's towards the north, south, east, or west. By simply rotating that disk, you can actually find out which direction exactly you're moving in, because the needle would always point in the north south direction no matter how you keep it. So let's determine the north and south pole in artificial magnets. How can we do it? So we can do this using the simple property of attraction or repulsion of like unlike poles and like poles respectively that we see in magnets. Okay, so we know that if we know the north pole, then we can see that the face of the magnet, or the pole of those magnets which are going to face towards the north, or which are going to repel away from the north pole of another magnet would be the north pole of these magnets. Therefore, for the U magnet or the horseshoe magnet, the north pole and south pole would be like this. For the bar magnet, it would be like this. For the circular magnet, it would be like this. For the ring magnet, the north and south pole are actually on the different faces or the different sides of the ring, right? So the top side would be north over here and the bottom side would be south. And then we have the cylindrical magnet, which is pretty much like a bar magnet, only thing is that it is cylindrical in shape. Let's go to the third property of magnets. What happens when a magnet breaks? Magnet breaks into two pieces, two or more pieces. Every individual piece actually develops its own poles, north and south poles. This property of magnets is what we call as the poles of a magnet cannot be isolated or separated. That is, the south pole is maintained, it is retained, and it keeps being the south pole, and the opposite pole simply becomes the north pole. When that magnet is further broken, the second piece becomes the south pole and the opposite side becomes the north pole. So this property is what we call as the poles of the magnet cannot be isolated. So it is very easy to experience this. If you have a bar magnet at home which is broken, you will see that you will not require any glue or anything. If you orient the magnet correctly, it basically sticks together because the broken ends will actually be opposite poles. So testing for magnets. What if you have an iron bar? How can you see if it is simply an iron bar which is magnetic in nature or whether it is actually a magnet which can attract other iron bars? Let's see how we can do this. How to identify if an iron bar is a magnet using another bar magnet. So to conduct the test, you will always require another bar magnet. Okay, the north and south pole of which you know. So when you bring, say, the end B towards the bar magnet, if it is getting attracted, you can see that it is getting attracted towards the north pole of your magnet. Now you test the iron bar for the other end, that is the end A. Okay, you see if it is getting attracted. Yes, it is getting attracted towards the magnet over here. So you can see that both ends of the iron bar are getting attracted towards our magnet. So what does this mean? This means that this iron bar is actually simply an iron bar and it is not a magnet. Because if it was a magnet, it would have poles. It would have north and south poles, and both the poles would not get attracted towards the north pole of the magnet. Only the south pole would have got attracted towards, and the other pole would have been repelled. Now let's see. Suppose this iron bar was actually a magnet. How would it behave? You can see that the end B is getting attracted towards the north pole of our bar magnet. And what about the end A? Oh, it's moving away. It's getting repelled from the north pole of our bar magnet, which means that this iron bar is actually a magnet. Then, in this case, the iron bar would actually be a magnet. The side A would actually be the north pole because it is getting repelled away from the north pole of the bar magnet, and the side B is actually the south pole because it is getting attracted towards the north pole of the magnet. So, this is the way in which we test for an object whether it's actually a magnet or not, and it tells that the only true test for magnetism is actually repulsion. You can actually see if another object is a magnet or not only if it repels, only one end of it actually repels another magnet, another pole of a magnet. Now let's talk about the applications of magnets in our day-to-day life. Magnets are used in many devices in our day-to-day life, starting from speakers to mics The MRI or the magnetic resonance imaging machines in hospitals, this black strip that you see in your credit cards or debit cards, which you swipe in an ATM or using a credit card machine, it's actually a magnetic strip. It's made up of magnetic material. Then your CD-ROMs and the CD readers or writers, they are also having magnets in them. Electromagnets are very, very useful in industries for separation of junk, which is made up of magnetic material, that is metal junk, metallic junk. It's also used definitely in building construction sites for lifting heavy metallic material from one place to another. Then definitely our compass is one of the most widespread applications of magnets. How does a fridge close? The fridge closes simply because on its own it can close, right? It's that you can make sure that no energy is wasted by keeping it open. This happens because the door is also made up of magnetic material. So let's see how we can take care of our magnets so they last us a long time. Magnets, because they can lose their magnetic property if they are not handled properly. Remember that most of the magnets which we use, they are temporary magnets. So if you don't take care of them, they can lose their magnetic property. So what can affect a magnet? See, heating, hammering, dropping the magnet several times from a height, improper storing. All of these things can affect the magnetic property. That is, the magnet can become less magnetic if you heat it, or it can completely lose its magnetism if you heat it, or if you are going to exert force on it, like by hammering it or by storing it improperly. So, what is the right way to store a magnet? Magnets are stored using keepers. So, what are the keepers? Keepers are simply iron bars which are used to, kind of protect, or they stick on to the poles of a magnet. And magnets are always stored in, bar magnets are always stored in pairs so that the north and south, they can attract each other and they stay together, but at the same time they are separated using a simple wooden board. So what are keepers? Keepers are iron bars or iron strips which are used to store magnets. if you're going to have if you're going to store bar magnets, you would require a pair of keepers, because there are two poles. You would require a pair of keepers. But if you want to use a U magnet, if you want to store a U magnet, you can simply use a single keeper just to protect the poles from losing their magnetic property. Another important thing to remember is that the magnets should never, even if you're going to store U magnets in pairs, they should never be stored in such a way that the unlike poles are facing each other. I mean, the like poles are facing each other. The unlike poles should be facing each other, and they should kind of stick onto each other, and that is the right way to store U magnets or horseshoe magnets also. So let's recap. We have learned about the properties of magnets, which are namely the directive property, that is that a strip of bar magnet would always face in the north-south direction of the earth. Then we learned that like poles of a magnet attract each other, whereas unlike poles of magnets repel each other. We also learned that the poles of a magnet cannot be isolated. So the magnetic field and its strength is always maximum at the poles. And we also learned the test for a true magnet. How can you identify a true magnet? By using another bar magnet. Repulsion is the only true test for magnetism. And we learned about the applications of magnets in our daily day-to-day life. And we learned how to take care of magnets by using keepers and wooden boards for bar magnets too, and also that the opposite poles of the magnets should be facing each other whenever we store magnets in pairs. Alright, dear kids, I hope you enjoyed learning about magical property of magnets. Now you know that it's not magic, but just science. See if you can do many more fun things with magnets and try to analyze where else magnets are used in our day-to-day life. I'll see you again in another video. Take care and keep learning. Bye bye.